Welcome to the Sun Today for the 20th of February 2022. Today we're going to be talking about storms and flares. Here is the daily summary that I posted on Twitter this morning. From panel 1 we can see that the sunspot number has dropped to about 46. We had a brief geomagnetic storm last night, and I'm going to be talking more about that later. The solar wind kicked up to about 512 kilometers per second. Frame 3 shows the sunspots, and mostly we have decaying regions. Active region 2953 is actually growing, and we have a new region on the northeast limb. This is not a surprise because we've been seeing so much activity over the back of the limb for the last few days, including a C5 flare, which you can see in panel 4 down here, which is the GOES X-ray plot. This is a long duration event, which means it's probably associated with a CME, as we shall see later. It's been 71 days since we had our last spotless day on the sun. Now we're getting up towards a record for this cycle so far. And we've had now 2 consecutive days with a C flare. We had one late yesterday and one early this morning. As I mentioned before, we had a brief geomagnetic storm. This raises 2 questions. 1, why did we have a geomagnetic storm? And 2, why was it brief? Here we have an image of the sun taken in the SDO AIA instrument's 193 angstrom channel. This is about 1,000,000 degrees or so. And there's this dark area up in the northwest. That is a coronal hole. Coronal holes are the sources of high-speed solar wind. You can see this here in the solar wind trace. The BZ component, which is the vertical component of the interplanetary magnetic field, went south suddenly at this time, which is the time of the event. And when it goes south, it's much more easy for the magnetic field in the interplanetary medium to connect with the Earth's magnetic field. And so that is likely causing a geomagnetic storm. Also at the same time, you can see there's been a steady increase in the speed of the solar wind from about 350 kilometers per second up to 500 kilometers per second, which is the evidence for the high-speed stream. And if you look at the KP index, which is a measure of geomagnetic activity, you can see it reached 5, which is technically a mild geomagnetic storm, a G1 storm. Now the interesting thing is, how long did that solar wind take to get here? Well, it's about 150 million kilometers from the sun to the Earth. And if it was moving at 500 kilometers per second, then that would take 83 hours. However, it probably wasn't always moving at 500 kilometers per second. It probably initially was moving much faster and has been slowed down by bumping in to the much slower paced solar wind. So 83 hours represents the longest time it would have taken to get from the sun. You can see here why the storm was so short. That was a very long, narrow coronal hole. That means that the stream of particles coming from that coronal hole passed past the Earth relatively quickly because it was quite narrow. You can actually see this yellow area here, which is the high-speed stream passing the Earth, the green dot with the E next to it. And it only takes a few hours for it to do that. Much stronger and larger streams will take longer to do so. I've probably mentioned this rule of thumb before, that long duration events, LDEs, produce coronal mass ejections, or at least a harbinger of a coronal mass ejection. Well, this morning we had a C5 flare, which was a long duration event. You can see it here in the bottom frame. And we were fortunate enough to catch it in the SDO AIA instrument in its helium-2 304 channel. You can see it's that bright area on the limb. A couple of hours later, the Soho-Lascaux coronagraph caught a very large coronal mass ejection being blasted out from the northeast part of the sun. This same region a couple of days ago produced that very, very spectacular coronal mass ejection. Why are long duration events associated with coronal mass ejections? When a coronal mass ejection blows out the corona, as it reconnects, it produces large hot loops which sit there for a very long time. So this is effectively a piece of evidence that the corona was opened up and is now closing back down again and heating as it does so. So what conclusions can we draw from all of this? The geomagnetic storm was caused by a high-speed solar wind stream from a coronal hole. It was a brief storm because the coronal hole was relatively narrow in longitude and the stream passed the Earth relatively quickly. The new region on the northeast limb produced a C5 flare, which was a long duration event. Actually, it's probably much larger because it was behind the limb, and that in turn caused the eruption and a CME. Now a new feature, something I'm calling a solar soliloquy. I'm going to show a 1-week movie from one of the channels that are observing the sun from various spacecraft. So sit down, relax, and enjoy the show. Today we're going to use the SDO HMI instruments and look at a magnetogram movie. This is a movie of the magnetic fields on the sun. So you're going to be able to see where the sunspots are, look for emerging regions, decaying regions, and in particular look at the motions of the magnetic fields, because they are the ones that drive all the activity that you see. So that's it for today. Thank you for watching. If you enjoyed the show, pass it on to some of your friends who might enjoy it. Otherwise, stay safe, and until next time, goodbye.